So let's dig into Unity shaders, and specifically we're going to get into the OPCD shaders that we're using in V4. So let's first of all talk about the OPCD shaders. So it's called the OPCD MAHS shader, and I'll talk a little bit more about what that MAHS means after, after. Okay. But for now, as an intro, you need to understand that this shader, okay, in the previous 3 video, we explained what a shader is. It's just code that really manipulates how we see light inside of a game. It was specifically written for the OPCD toolset. That means it is, I don't want to say it's proprietary, but it is protected as intellectual property. Okay, I believe it was written by DPRoberts. Could have been John Meyer. Those both had a hand in it, and they worked together to fine tune it for sure. And I think Stinger Eye probably had a lot to do with it as well, but it was written and it is custom code. The concept of the red, blue, green, black channels that we've been talking about, although using channels like that isn't new, but it is unique to this shader. And I haven't seen other shaders use those channels in the way that this is. So it is somewhat unique in that case. And because we're doing this, it allows us to do things like vertex painting. It allows us to do blends. Sat shading is built into this shader as well. We haven't talked too much about that, but it is covered later on in the video series and has some other functions as well. It is the primary control point for those channels and editing those channels. So when you want to do vert painting and you want to do different types of things, you're going to edit those inside the shader. Okay, and there's lots of buttons. There's lots of nerdobs in there. It leverages some other things that are somewhat unique, which are this idea of an array. So I know you're not going to understand what an array is now, but we're going to be using arrays for the base, detail, and normal textures within this shader. But just be aware of that term array because it's going to come up again and it becomes very important for customizing the different materials that are used in the OPCD MAHS shader. Now, before we go too much deeper into the MAHS shader, let's talk about a typical shader. And if you go into Unity and you have a game object in Unity, remember our model, okay? We're going to dress that model. We're going to put makeup on the model. We're going to put clothes on the model, and we're going to use a shader to kind of manipulate that. So the typical shader, this is very typical, and all shaders are somewhat different. But the shader is going to have a bunch of different things that it can consume, more or less, to give something a specific look. So one of the things that a shader can consume is what we call the albedo or base. It is really the color map. Okay, what color is this thing going to be? And the example that I'm using here is a rock. And I'm going to show you the picture of the rock when I'm done with this. But this image that you see down here is really the color of that rock, and that's it. And where these certain colors exist. Now, this image that you see will get mapped to the rock so that the dark colors are in certain areas of the rock and the lighter colors are in other areas, but it is just color. That's it. Nothing to do with anything else at that point. When you say, what do you mean by anything else? Well, this is what I mean by anything else, which is metallic. So what is metallic? Metallic is like the shininess, also sometimes referred to as smoothness. So I like to think of the most metallic thing that I can think of is a pinball ball, you know, that you hit in the pinball machines. It's like metal, it's shiny, and everything reflects off of it. So that is extremely metallic. It's extremely smooth. And in this case, rocks are not metallic. Okay, they don't really reflect much light. They tend to absorb light, and the light is flat on them. If you can understand what flat means, like you ever see a car as shiny, but you have cars that are sometimes flat black. Well, that's what metallic kind of controls. And what you're seeing here is actually a metallic map. In this case, it means that our rock, because it's all black here, is going to be absorbing light, and it's not going to be really shiny. Now, these things can be adjusted, okay? We can actually adjust the color of the albedo. We can actually adjust to make things more or less shiny as well. They have sliders. And I'll show you some of that stuff here when we get to our rock example when I bring that up. So another thing that this shader can absorb and use is a thing called a normal map. Now this one looks a little funky, right? It looks somewhat similar to this and the geometry is the same, but what this normal map controls is really shadowing and the fine texturing of the object. Is that object like rough? okay? And in this case, our rocks are rough. They've got like bumps and things on them, and that's what this is depicting on here, is this is a map of determining how rough the surface is of our model in the game. So that's what a normal map does. Now we also have a thing called a height map, and people get these confused, but they work somewhat differently. Think of a normal map as fake roughness, where a height map is really true roughness. If you cast a shadow from something with just a normal map, the height of whatever this normal map creates is an illusion, and that the shadow won't actually depict that. Whereas a height map, it does impact the shadowing of the object. And it is these two things combined that really give an object depth. Okay. Now you can use one, you can use the other, and when you implement them, the look is very subtle, but you can see the differences. Okay. Go ahead and Google it. There's lots of information on the differences between those two, but just understand that this is more or less like the texture of the object. Okay. So we got color, shininess, and these two are the texture. And then we have occlusion. And what this controls is another lighting trick, which controls the reflection of indirect light. Well, what is indirect light? Indirect light is light that has bounced off another object before it hitting this object. Okay, so sunlight, when it comes down, is direct light, but if sunlight hits the side of a building and then hits your object, that is indirect light. And occlusion controls how indirect light is treated on your object because it's coming in at different angles. It gives it even more depth. It's all these things that influence something, how it looks in real life, and that's what we're trying to get inside the game, is things that look real. So all these things together is what the shader combines, okay, ultimately to give something a particular look, okay? Now, again, this is a very simple standard shader. So let's show one. So here is our rock, and what I showed you in the previous, all these maps and all these images are actually from this rock. And so what it does, when I highlighted this rock, I went over here and it's just using the Unity standard shader. And you can see that I can assign the albedo, which is the color, the metallic, and I can control the smoothness. So how much shininess this thing has. Now it's a rock, so it's all the way down at 0. And here's the normal map and the height map, and I can control how much influence they have as well. I can make it so it's even more bumpier. Things, if you make it too much, it starts to get a little funky looking. And here's the occlusion. And then we actually have things like detail masks, okay, which can impact things as well. That's another type of mask, and that's actually really important when we talk about the OPCD tools, which gives even more detail to the color piece of this. And we have some secondary maps in here, which is actually unique to this standard shader. But you can see there's a lot of other things in here other than these. That's why I'm saying this is a very simple shader, which I just talked about. So now let's dig into the OPCD MAHS shader. So just so you know, the MAHS shader, it stands for Open Platform Course Design Metallic Ambient Height Smoothest Shader. Thank God I don't have to say that every time, right? The reason being is that, well, I'm going to talk to you about why it's called that in a minute here. Well, basically, it allows us, and what's special about this, and it was written specifically for the use in the OPCD tools. It was a custom shader written for Unity by the authors of the design tools, DPR, John Meyer, Sting, and it allows us to pack a lot of textures into a single material by leveraging these things called channels and arrays. So then you apply that single material to your mesh, and you have essentially access to do things like vert painting. You have access to do things like blends, all right? So it's a very custom shader that we're using. Now, so it's leveraging these things called channels and arrays. You guys already know what channels are. You've got 4 channels: red, blue, green, black. But you're not familiar probably with arrays. So arrays are another method of allowing us to pack textures into a material. And essentially, arrays are a flipbook or a listing of textures, and they reside in that material. And we can actually manipulate those arrays. You can add your own custom textures to it. That's not what we're going to cover in these immediate videos. That might be a more advanced topic later on in the series. But you're given these arrays as part of the base project. They're already created for you. They already contain all these textures, and you have a lot of flexibility on which ones you want to use. Okay. There are three primary arrays. So we talked earlier about a normal shader, and you know that that shader has like a base texture. It has a normal map. It has height maps. It has metallic. It has smoothness. So there are three arrays used in the OPCD MAHS folder that allow us to have multiple different types of textures inside of that material. One of the arrays is called the base array, and that is our base color, our primary color. So that influences really the overall color of what the material is going to look like. And then we have another array which contains a bunch of textures, and it's called the detail array. So that has a secondary color that manipulates that base array, and it also has the MAHS in it. And so what is important there? Remember in the previous simple shader that shaders had things called metallic, ambient, height, and smoothness? Well, they're all combined, okay, into a single texture inside of that detail array. Now it's getting a little confusing. Don't worry, it's going to make sense. We're going to go, I'm going to explain this a little bit differently in a second. And then we have the last array, which contains all of our normal textures, and it's called the normal array. So that's what gives a lot of our materials, like our fairways and roughs, it gives it a little bit more depth, okay? So each of these channels, okay, accesses the appropriate textures through its index or place in the array. So we've got these arrays, those three different arrays, which have a listing of textures in there. Well, we need to select which texture we want to use inside of our channel, and we do that through its index, okay, which is just a simple number saying, I want to find texture number 6 in the base array, okay, so that's the index. So a little bit more here. So we know that the OPCD MAHS shader gives us channels, okay? It gives us a green channel, it gives us a red channel, it gives us a blue channel, and it gives us a black channel. And each of those channels can operate independently as far as what textures we're going to assign to each one. So how does that work with the OPCD MAHS shader and the arrays? Well, let's take all these because they're all treated the same. Okay, so I can't, there's going to be a lot of stuff filled out on the screen, and I just want to make sure that you're aware that what I'm going to be doing is not just limited to the green channel. It can be applied to all of them and all of them independently. So let's start here. We can assign a base texture to that green channel. And remember what I said, the base texture is like the base color. And here's an example, and this is the base color of most of our grass covered meshes. So like our fairway, semi-rough, rough, deep rough, all really use that same base color because they all are basically the same color. It's grass, right? And where does that base array come from? Well, I'm sorry, where does that base texture come from? Well, it comes from the base array, and it's assigned through the index. Now, I just happen to know, because this one's very popular, that this is base array index 2. All right, so 0, 1, yes, 2. It's the third one. I just happen to know that because I've seen it so often. But there actually is a different base texture for bunkers, for instance. Okay, there's a different base texture for pine straw. And the bunker one would look more like white, okay? Pine straw looks more brown, okay? So that's the base color, and that's how it's assigned, okay? And remember, this can go to any of our channels, okay? Our blue channel could have a completely different base color than our green channel and our red channel and our black channel. So the next thing on there is our detail, okay, our detail texture. And in the case of a rough, okay, this detail texture provides more detail to make this base color look more like grass, okay? Now, in the case of sand, okay, this would be white, and this would be more like, it would have like rake lines in it, or more like a rocky detail to it, depending on what kind of sand look you're going for. And where does this detail, how does this get assigned? Well, from the detail array, from the index of the detail array. So this detail array will have a bunch of detailed textures into it, and we pick the appropriate index, 0, 1, 2, 3, 4, 5, 6, 7, all the way up, to pick the appropriate detail texture, and then we assign that to whatever channel we want it in. Again, green, black, blue, red. So what's the next thing on here? We have our metallic, ambient, height map or height, and smoothness. And we talked in the previous video that these are all separate textures, but some of the magic that happens in OPCD and what those guys did is they were able to combine all those things into one texture. And this texture, okay, we have our green channels up here. These textures in and of themselves have their own channels. And what they're doing is they're taking the metallic, the ambient, which is occlusion, the height map, the smoothness, and they're combining it into a single texture. And that texture is also listed as one of the textures in the detail array. So we reach out to this index as well to pull this information in and assign it to channels. And again, these can all, although these are in the same texture, remember that this index here, this MAHS texture, again, can be assigned to any of these channels up here. And then lastly, we have our normal map. And if you recall, a normal map gives us depth, gives us the height. So this one actually is the normal map of like a root system. So like a forest floor or the base of a tree where the roots are kind of bumping up. I put that one in here because it's kind of easy to see that. And just like before, our normal map comes from what? A normal array and an index in that normal array. And all these things together, okay, define what a particular channel will look like. In this case, maybe we assigned what you see here to the green channel. Now, let's move forward and talk about, whoops, I went too far forward. You lost the surprise here. It was just took a lot to load that slide. Oh, it did it again. So our MAHS shader, okay, can take the green, red, blue, and black channel, and then each one of those, what I did is I shrunk that previous screen, and so we have our base, our detail, our MAHS, and our normal, all that can be customized to form the green channel. Same thing with the red, same thing with the blue, same thing with the black, and then ultimately it was up to the shader. If it's all going to be, if the entire mesh is red, then it's going to get the information from all this stuff down here. Now, if you vert paint some green, it's going to get all that information from what you assigned here. Same thing for blue, same thing for black. And you can customize all these. You can change, okay, the base of the red channel, or you can just change the hue of the base in the red channel, and it only impacts the red channel. It does not impact the blue or the black. So now you can see a lot of the power with this shader. And there are lots of nerd knobs here, and I haven't even got into those yet, but I just want to make sure you're aware of the theory of what's happening with the OPCD MAHS shader.